Now we want to discuss about derivative of logarithmic functions. So we want to find out what is derivative of log of x base a. So one way to go about that is as follows. So you say, well, let y be log of x base a. Now convert this into exponential function. We get a to the y equals to x. Note that log is an inverse of exponential function. And so whenever you want to find results about log, often you would go back to exponential functions. Yeah. So this is one of those cases. So I convert it into exponential function. Now we already know the derivative of exponential function. So take derivative with respect to x on both sides. So d by dx of a to the power x is d by dx of x. Now, derivative of a to the power x is a to the power x is a to the power x ln a. So derivative of a to the power y is a to the power y ln a multiplied by dy by dx. This extra, quote unquote, extra dy by dx is the consequence of the chain rule. So therefore we get from here dy by dx is 1 by a to the power y ln a. Now we were looking for derivative of this. So we found out dy by dx, which is the derivative of log of x base a. Now we should write everything back in terms of x. So a to the power y is x. So we get x ln a. So this is your derivative of log of x base a, which is 1 over x ln a. Note that ln a is log base e of a. Now, this formula simplifies further. If your a is e, then log of x base e derivative is 1 by x ln e, but ln e is 1. So we get 1 by x. And this log of x base e is written as ln x. So derivative of ln x is 1 over x. So now let's use that, and with the chain rule, try to find out what is derivative in these cases. So can you go ahead and do this problem, please? So here we have to employ the chain rule. So we get dy by dx is going to be 1 by 3x squared plus e to the x times ln 2 multiplied by derivative of inside, which is 3x squared plus e to the power x. Now, in this case, we get 1 over 3x squared plus e to the power x times ln 2 multiplied by derivative of 3x squared is 6x and derivative of e to the x is e to the x. Now let's look at the next one. So we have dy by dx. So derivative of ln x is 1 over x. So 1 upon x plus square root of x squared minus 1 multiplied by d by dx of inside derivative of x plus square root of x squared minus 1. This is going to be 1 upon x plus square root of x squared minus 1. Derivative of x is 1. What is derivative of square root x? So derivative of square root x is 1 by 2 root x. So 1 by 2 root of x squared minus 1 multiplied by derivative of x squared minus 1, which is 2x. So now these guys will cancel off. So you are left, and then when you cross multiply, you see that this is going to be on top, you get x square plus 1 plus x divided by square root of x square plus 1. Let's make it clearer. So x square plus 1 and then divided by x plus square root of x square minus 1. These are minus ones, sorry. Now these guys will cancel off. You are left with 1 upon x squared minus 1. So this is the answer. Now let's look at the next one, y equals to square root of ln x. So in this case, first we'll have the outermost function is square root of x, and derivative of square root of x is 1 upon 2 root x. So 1 upon 2 root of ln x multiplied by dx of inside function, which is ln x. This is going to be 1 by 2 root of ln x times 1 over x. Let's move on to the next one. So y equals to ln of square root of x. Now either you employ the chain rule and go about it, or notice the following, that this is same as x to the power half, but the property of log tells you that this is going to be half ln x. So your y is half ln x. So therefore dy by dx is going to be 1 by 2 times derivative of ln x is 1 over x, so 1 by 2x. So these are the few properties of log you should be able to see. Let me revisit it for you. So log of a log of x plus log of y base, if the bases are same, this can be written as log of xy base a, log of x base a minus log of y base a is log of x over y base a. Then we have log of x to the power r base a is r log x base a, and there's a base change formula, which basically is log of x base a is log of x over log of a to base b. What is b? B is any, for any b, a a real number which is greater than 0 and b is not 1. So these are the laws of log. Okay. So now let's look at this problem now. Now instead of trying to employ the chain rule, why not break it using properties of log? And then so first we'll basically simplify it. So this is going to be log of x squared minus log of a by b is log a minus log b, right? So here log of x by x over y is log x minus log y. So this is going to be ln of x plus 3 the whole power 4. This is going to be 2 ln x minus 4 ln of x plus 3. Note that no derivative is taken yet. We are just rewriting it so that taking the derivative becomes easy. So we have dy by dx is 2 times derivative of ln x is 1 over x minus 4 times derivative of x ln of x plus 3 is 1 over x plus 3 multiplied by derivative of inside, which is 1. Right, so I don't need to write that. So this is the derivative. If you wish, you can simplify. Let's move on to the next problem now. So you saw how if you had ln, the thing simplifies. So we can use that technique to simplify this function. Now, suppose if you want to directly use, if you want to apply, if you want to take derivative directly, you will have to use quotient rule. Then there are two product rules each time you do this part. And then there are some chain rules as well. So it's very tedious if you want to do it directly. However, you saw that if you do the log of complicated expression with multiplication and division, then log simplifies it. So let's basically do that here. What we'll do is we'll use, take ln on both sides. So we get ln y equals to ln of cube root of x cube times fifth root of x cube plus 1 divided by 2x plus 1 to the power 3. Right. So this is going to be ln of, now ln of a divided by b is ln a minus ln b. So I'm going to write this as power because I'm going to use it soon. So x cube plus 1 to the power 1 by 5 minus ln of 2x plus 1 to the power 3. Now you can break the multiplications as well and then bring the power down. So I'm going to do both of them simultaneously. So 3 by 4 ln x plus 1 by 5 ln of x cubed plus 1 minus 3 ln of 2x plus 1. So this is a simplification so far, no derivative taking. Now take derivative on both sides. So what is derivative of ln y? 1 by y dy by dx. 3 by 4 as it is. Derivative of ln x is 1 over x plus 1 by 5. Derivative of ln of something is 1 over that thing multiplied by d by dx of x cubed plus 1, chain rule, minus 3 upon 2 plus x times d by dx of 2x plus 1. So therefore, what do we get? So this side simplifies 3 by 4x plus 1 by 5 x cubed plus 1, and on top you have derivative of x cubed, which is 3x squared, minus 3 times 3 divided by 2x plus 1 multiplied by derivative of 2x, which is 2. So this is going to be 6. So this is your 1 by y dy by dx. So you can say dy by dx is going to be y times this, where y is above. As above. So such a process is called logarithmic differentiation. You're using log to simplify and then differentiate. Now, how about this problem? So we'll take ln on both sides. So we get ln y equals to ln of x power x squared. And the power comes down. So we have x squared ln x. So take derivative on both sides. So this implies derivative of this. So let me just write d by dx of ln y equals to d by dx of x squared ln x. Now on this side you get 1 by y times dy by dx. On the other hand, you have to use the product rule. So x squared times derivative of ln x, which is 1 over x, plus ln x times derivative of x squared, which is 2x. So we get dy by dx equals to So let's simplify this. So x plus 2x ln x multiplied by y. This y comes on the other side. And we put back what our y is. Y is x to the power x squared. So we get x plus 2x ln x. Yeah. Note that the growth rate of this function is different. It's variable to the power variable, right? So you can't use one of those power rules or exponential rules here. Now, how about this one? Y equals to absolute value of ln x. So note that why are we talking about this? Now note domain of ln x is, so if domain of this function is 0 to infinity, whereas domain of ln of absolute value of x is minus infinity to 0, union 0 to infinity. So in some sense, this function is better because it's defined almost, so defined on all real numbers except at 0. So you have y equals to ln x. Now consider two cases. Case 1, ln of absolute value of x. So case 1, if x is greater than 0, then we have y equals to ln of x. This implies dy by dx is 1 over x. Case 2, if x is less than 0, then what do we get? Absolute value of x is minus x. Note that minus x is greater than 0, right? And then you get y equals to ln of minus x. So therefore, dy by dx is going to be 1 upon minus x times d by dx of minus x, which is going to be what? Minus 1 upon minus x, which is 1 over x. So in both the cases, you can now generalize that d by dx of ln of absolute value of x is 1 over x. Note that this is always going to be since x goes to 0, for x very close to 0, 1 plus x is going to be positive, right? So this is same as a limit as x goes to 0 of ln of 1 plus x to the power 1 over x. This is going to be limit as x goes to 0 of ln of 1 plus x over x. Later on, you'll be able to see that this limit is going to be, this limit is 1. We'll see that later. Why is that the case? Therefore, what do we get? Ln of this limit L is 1. This implies L is E. So we will get to the details of this when we do L'Hopital also.